Hey everyone, short lesson here on transformations. I gotta tell you, this could be the most valuable lesson you will ever have in math. It's that huge. Okay, yet it's not that difficult. Let's talk about transformations. Bang. I guess it begins with a look at graphs you should know. And there's lots of them, of course. Let's go here. Y equals mx plus b when nobody is higher than first power. Y to the first, x to the first, everything else. All right, that's a line, rar. Okay, and it's diagonal because it has slope, positive or negative. All right, well, what if it's just plain old y equals or x equals? Well, okay, y equals will have no slope because there's no x, and it'll go sideways, nice and flat, no slope, zero slope is that. All right, x equals, of course, straight up and down, undefined slope. Graphs, you should know. How about when x is squared? Okay, any even will look like a parabola, a smile, okay, or a frown if it's negative, and odds. Okay, y equals x to the third or x to the fifth or x to the 313. Okay, they will look like this here, squiggly, starting low and finishing high. Square root graph, half a parabola on its side. And boom, three more. Yeah, three more. One was added late. The absolute value absolutely looks like a V. All right, what about the parabola when y is squared instead of x? Goes sideways, and of course, the rational function graph when you have x downstairs here will look like so with both a horizontal and a vertical asymptote. Graphs, you should know. Okay, now if you know those, let's talk about shifting them around. Here they are, three huge rules of transformation. The first, and think geometry here, when you did the transformations there, the slide was called a translation, the flip was called a reflection, and the spin was called a rotation. Okay, you also did dilations, which made them bigger or smaller. Well, let's take a look at the first rule. It's the slide, the dilation. Okay, what happens when you add or subtract a constant, a number, to a function? Okay, I say it's going to matter whether or not it's inside or, okay, well, that's a lot. That's outside. And this C is inside. Okay, remember this, inside means side to side. And look where that movement is for inside. It'll be sideways, but it's opposite of what you would think if it's coming out of the parentheses here. Negative actually moves you to the right, positive backwards to the left. And if it's outside the function, like this top one, that moves it up and down as you would expect. Plus moves it up, minus moves it down. Okay, so if we looked at a little Desmos here, call that up. One second. Calling Desmos. Okay, got it. Here we are. Take a look here. And this one is y equals x. Let's go x squared. Stick with the parabolas for now. All right, so what did we say? All right, if you have y equals x squared, and then you add something like 3, That's outside, so it should move it up, and it does, up 3. Okay, what if we change that to minus? Moves down 3. Okay, and what if this was all in parentheses? Minus actually moves it 3 to the right. Plus backwards 3. Okay, so that is rule number 1 in transformations. Okay, 1 down, 2 to go. Short and sweet, these notes, just like me. The second one is the reflection, the flip, if you will. Once again, what matters most? Is it inside or outside? If the negative sign is out here, that's going to flip it up and down. And if it's inside, it's flip side to side. Okay? So let's take a quick look at Desmos again. And yes, let's stick here. Okay, this negative is outside and it flipped it from facing up to down. And bad example, it's that one. Let's see, let's do this one. Yeah, y equals, all right, and we'll pause there.
Good afternoon, Hayfield, and part of the interruption. This is just
okay, back to it here. Let's do absolute value. Or maybe let's do square root. Yeah, let's do that. Square root. Just saw it. There it is. Of x. Yeah, this will be a good one. All right. So again, where is the negative placed? If it's outside, it flips from high to low, up, down. And if it's inside, it flips side to side, flips from quadrant 1 over to quadrant 2. Okay, so there's 2 down, 1 to go. You've got the slides, and now you've got the flips. Okay, and the third and final one. Okay, here is the dilation, if you will, making it bigger or smaller. In this case, we'll have to talk about the picture itself. Okay, it's really what you multiply by. If you multiply by a big number, bigger than 1, it's going to get skinnier, taller, narrower. And if you multiply by a fraction, okay, wider, flattens out, anything you want to use to describe that. Okay, you make me half as, multiply me by half, I'm half as tall. If you multiply me by 2, I get taller and a little skinnier. Okay, so let's look at Desmos on this one. Okay, and let's go back to the parabola. So if we multiply by a big number, suddenly, actually, let's go here. So the original one is in red, supposed to be, and this one in blue should be narrower because we multiplied by a big number. Okay, what if we multiplied by a fraction like a half, 0.5, should be half as tall or wider. Okay, and those are your 3 rules for transformation. So now there's nothing you can't move using these 3 rules. That'll do it. Go get them. Okay, and I guess I should say this. All right, using these rules, it doesn't matter which of those graphs that you're using. that we started this lesson with. All right, they all shift based on these transformation rules, and that goes for your future. Look into trig graphs and so forth. They will all just be a different shape, but the same shifts will happen as a result of these rules. All right. There you go.